one unbiased disk, right, has a single dot marked on one side and two dots marked on the other side. Okay, Ilyu, stop talking. The disk and an unbiased die are thrown, and then one random variable x, right, is the sum of the numbers of the dots showing on the disk and on the top of the die. So the disk, right, the score can be a single dot or two dots, right? The die can be 1, 2, 3, 4, 5, 6. So that means from here, what we need to do is we need to tabulate. We need to tabulate the score of the die. Okay. So we know that, okay, first of all, if not very clear, you can just write that. So the disk can take on the values 1, 2. The die can take on the values 1, 2, 3, 4, 5, 6. Okay, so it's very confusing. Oh, you just carefully, slowly, you just write out, you tabulate. That means you think about it. Okay, so here it could be that to get the score, where x is the sum of the die. So this one, first of all, x could be equals to 2, right? So 2 will just be like 1 plus 1. Okay, so given that, you know, for the probability of x equals to x, if you get 2, then it will just be like getting 1 on the disk, probability half. Okay, so for the disk, right, if I'm going to get this probability like 1, 2, the probability of a disk, right, equals to, right, so it just equals like 1 over half, 1 over half. Okay, but for the die, you know, it'll be 1 over 6, 1 over 6. So you can easily work out to get a 2, right, on the total score. It's like 1 over 6 times 1 over 2, which is 1 over 12. Okay, then I want to get a score of 3. If I want to get a score of 3, it could be that, you know, I'm getting, you know, maybe the disk shows me 1, the die shows me 2. Alright, this will just be what? Half multiplied by 1 over 6, correct? And then this could be that the disk shows me 2 and the die shows me 1. Again, this could be half, 1 over half, half, 1 over 2, 1 over 6. So if I multiply them and add them together, if I add together, I'm just going to get 2 over 12. Right, 1 over 12, 1 over 12. So what all you do is actually just simplifying and adding all the distributions together. And for 4, it's the same. So it could be 1, 3. This could show you 1, the die could show you 3. This could show you 2, the die could show you 2 as well. Right, can the disk show you 3? Cannot, right? So these are the only 2 possibilities. So you also have 2 over 12. And you can work out the rest. I mean, I'm sure you're smart enough. You can work out the rest on your own. And then you can get that, actually obtain easily the probability distribution function of the sum of x, where x is the sum of the score, okay, on the disk and on the die. But you must make sure that this one is done correctly. If this one is not done correctly, then you're going to lose like accuracy marks later on. Alright, the first one, right, we need to show that the probability of x greater than or equals to set 4, given that it's less than or equals to 7, is 8 over 11. So we just go by definition. The probability of x less than or equals to 4, given that is x is less than or equals to 7, if you were to do this like a given b is like probability of a intersect b, so this is like x has to be fulfilled greater than 4 equals 4. It also has to be less than or equals to 7. Okay, below is given, so over probability of x less than or equals to 7. So from here, right, after that, how do we go on? Right, so what is the probability of x is between 4 and 7? So here you can just sum. Right, you just sum. Basically, you sum from probability x equals to 4 all the way from probability x equals to 7. 4, 5, 6, 7. And you should have 8 over 12. Right, easily you should have 8 over 12. And in the denominator, for x to be less than 1 over 7, less than or equal to 7, it's just like, it's basically everything here. Or you can take 1 minus this, right? So it's just like 1 minus 11, 1 over 12 is like 11 over 12. And you obtain the answer easily to be 8 over 11. Okay, now this is for part 1. Any question? No question, right? Okay, so got question also I cannot answer you. Of course, you're in the video. Okay, so EX, write down EX. So, and then show that the value of x equals to 1906. So EX, very simple, would just be the summation based on definition of X with its attached probability. Alright, so basically we just follow, make sure that realize that everything lies on the fact that your table is correct. So after you just say 2, 1 over 12, 3, 2, 12, 4, 2, 12. So after that, you just multiply. This is 2 times 1 over 12 plus 3 with its probability, which is 2 over 12. Okay, I mean you can put together like 4 and 5 and 6 and 7 and 8, and with its attached probability will be 2 over 12. Okay, please don't talk, listen. Okay, please listen. Okay, so 2 over 12 plus 2 over 12 plus 7, 2 over 12 plus 8, 1 over 12. Okay, and the answer will just come out to be simple, which is just 60 over 12. Answer will be equals to 5. Alright, and next one, we are required to find the variance of X. So we are required to find variance of X. Variance of X will just be the E of X squared minus EX whole thing squared. Alright, so what's the E of X squared? E of X squared, again, just be the summation. Okay, we need to find EX squared first. So EX squared will just be the summation of X squared together with its attached probability. So basically, whatever is inside here, that becomes like the data value that we are summing with the attached probability. Okay, so this is basically exactly like almost like EX. The way it's also a type of average. X squared, which is 2. Okay, we have the X squared will be 2 square, 3 square, right? 4 square, 5 square, 6 square, 7 square, 8 square. And what is the attached probability? Again, it will still be 1 over 12, 2 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 over 12, 1 over 12. Right? And we add them up together. Alright, and the answer just comes out to be 338 over 212, right? So I hope you get this answer. Alright, then following which, we just plug it back into this formula, the variance of X. EX squared, as we have found, is 338 over 12. EX, as we have found, is 5, so 5 squared. Yeah, because we are using EX, remember we are using the formula EX squared minus EX whole thing squared. Right, this is the formula that we're using. With that, this will give us 19 over 6. Sure. Okay, next one will be part 1. So part 1, we are required to find 2 independent observations, x1 and x2, taken of X. So we take note that we are not finding 2x, we are finding x1 plus x2. So we want to find x1 plus x2. So number 1, we need to find the variance of x1 minus x2. So by definition, the variance of x1 minus x2 is just the variance of x1 plus variance of x2. Okay, just the variance of x1 minus x2 is just the variance of x1 plus the variance of x2. So it's just 19 over 6 plus 19 over 6, which will give you 19 over 3. Alright, so by definition, we know this. Then, next one, I need to find the probability that x1 minus x2 is greater than equals to 5. Right, so I will think about it. This means what? I mean, x1 has to be a bigger one, x2 has to be a smaller one. And try looking at all the possibilities that you have in your diagram. This would mean involving the total of 3 cases. First one, x1 can be 7, x2 can be 2, x1 can be 8, x2 can be 2, so it can be 6, right? Plus the fact that probability of x1 equals to 8 and x2 can be equals to 3. Now adding all this together, now x1 equals to 7, you have 2 over 12. x2 equals to 2, you have 1 over 12. Plus x1 equals to 8, you have 1 over 12. x2 equals to 2, you have 1 over 12. x1 equals to 8, 1 over 12. x2 equals to 3, 2 over 12. And the final answer comes out to be 5 over 144. Okay, that is for question 1.